Okay, 3.6 atomic structure and periodic table. So we did talk about what is the L. So this is orbitals. Could be 0, 1, 2, 3. If the L is 0, we call it S orbital. L is 1 is P orbital, L2 is D orbital, 3 is F orbital. It's coming from these words. S for sharp, P for principal, D for diffuse, and F for fundamental. Anyway, electron in the orbitals, if you have 4 quantum numbers, right? Energy level, N is a shell, L is orbital shape, subshell, and ML is orbital orientation, and MS is electron spin. We did talk about that before. You can still read this definition if you want. Now we want to see how we can create this energy level. Okay. Keep in mind, for S orbital, you just have one box. It can occupy just 2 electrons. One is spin up, one is spin down. For P orbital, the maximum, you have 3 boxes. In each box, you can have 2 electrons. One is spin up, the maximum 2 electrons. One is spin up, one is spin down. D orbital, it has 5 boxes. 4, 5 again. In each box, you can have 2 electrons, right? And F orbital is 7. Just make it larger. 1, 2, 3, 4, 5, 6, 7. Okay, I'm not putting this up and down. It's the same way. So here, 2 maximum electron here you could have. You could have 2, so like 3, 6 maximum electron. 2, 3, 4, 5. 5 multiplied by 2 is 10 maximum electron. And 7 multiplied by 2 is 14 maximum electron could be in it. So in each atom that has certain amount of the electrons, want to see what is the electron energy level configurations. And this is what I'm going to show you. How do we come up with this energy level? How do we set them up? Okay. The first thing you need to know is the Pauli exclusion principle. What is it? Just saying that if you want to fill these orbitals, for example, you have 3, you want to fill, this is the P orbital, it has like 3 boxes. You have 3 electrons there. How do you feel that? Do you feel like this? No, wrong. Pauli exclusive principle said that you have 3 electrons. These 3 electrons need to go first to be unpaired on each box, and then you pair it. If you have a 4th one, right? Let's say you have 4 on here. This is wrong. No, this is right, sorry. You have 3 electrons, you cannot do that. First, you have to put it in unpaired. And then if you want to fill it, the next one comes and will be paired here. It's coming later as well, so. Okay, first thing you need to know, how do we do that? So you remember that I said first energy level when N is equal to 1. L is from 0 to N minus 1. N minus 1 is 0, so it's just 0. Okay. So 0 is S orbital. You just have for energy level 1, you have S orbital. It's just S. Then N is 2. What is L? It's from 0 to 1. So it's just 0 and 1. So this is S orbital. This is p orbital, right? For energy level 3, L is 0 to n minus 1, 0 to 2. 0 to 2 is 0, 1, and 2. This is S, P, and D orbital. Okay, the same way you can do it for N4. L 0, 1, 2, 3, S, P, D, F. In this textbook, they're not being more than F. After that is G. Anyway, I'm doing that because you need to draw this diagram here, but you need to understand what's going on. So I start with 1s. See 1s, it means the energy level 1, you just have s orbital. In second energy level 2, you have s, and you have p orbital, so I put 2p. Okay, this is n. With the energy level, I have s and p. In the third energy level, you have s, you have p, and you have d. Okay. In the fourth energy level, you have s, you have p, you have d, and you have f. Fifth energy level, s, p, d, f. We have g, but you really don't need to write it down. 6, just continue until F and G, right? So as you see, 6 and 7 is written here, but for me it's not. Then you need to put this arrow here. I'm gonna do it with different color. So the arrow here goes diagonally. So it's like that. Go through 1s. Here is go through 2s. Going through 2p, 3s, then 3p, 4s. This is diagonal ones. Okay. All right. You just need to be able to draw that on your own, the first things. Then if an atom is given to you, like what? See, what does this atom belong to? Let's find an example. This is Pauli squared. Let me just go down here. Do you want to do the electron level of the oxygen? I know oxygen has 16 electrons, right? Oh, sorry, it has an atomic number of 8. So it has 8 electrons. If I want to do that, so the first one is 1s. 1s. Then it go to the 2s. See, 1s, 2s, and then 2p, 3s. Then 3s. And then it go through 3p, 4s. Let me just see if it's enough or not. So for s, we just have 2 electrons. For s, we have maximum 2 electrons. And for p, we have 6 electrons, right? 6, 7, 8, 9, 10. Okay, so it's extra. So means how many electrons should be in p orbital here? Make it 8 electrons because oxygen is 8. So it's going to be 4 plus 4, right? I just need to erase that. I know this is going on. but I need to write an energy level. The energy level, the lowest one is 1s. I just put a circle. This is my 1s. Here's 2 electron on it. Means it's paired, right? One or up down. Then it's going to 2s, so it's 2s. So its orbital will just have one circle, and it's filled 1, 2 electron. And then I go to the 2p. For p, we have 3 circle, 1, 2, 3. When you want to fill that, make sure you first put them as unpaired, 1, 2, 3. And the fourth one will be paired with this, according to the Pauli exclusion principle. This will be energy level diagram for oxygen. All right, so here is for iron atom. The iron atom, how many electrons does it have? I can go look at the periodic table quickly for this. Go to the periodic table, I'll see that iron Fe has 26 electrons. So coming back here, can erase this one. So it has 26 electron. If I want to draw that, so first is 1s, then it's go to the 2s here, then 2p, 3s, 2p, then 3s, then 3s, then 3p, 4s, okay, 3p, 4s. I'll just fill that. So it's 2 electron here, 2 electron. That was 26 electron total. So electron here is 6 electron, here is 2, 6, 2. So what's this 10 here? It's 20, so I need more. After 4s, you go to 3d. 3d. So in 3d, maximum get 10 electrons. 20. So you just need 6 more electrons. Let's have 6 here. I'll just do the energy level of that. So first is 1s coming, as you see, 2 filled, then 2s is filled, then 2p is filled, then 3s is filled, 3p is filled, 4s is filled. But when you want to do the 3d, you just put 5 circle, 1, 2, 3, 4, 5, 6 electron, right? So you just put that unpaired, 1, 2, 3, 4, 5, and then 6 of them will be paired with that. As you see, it's there. Just going to erase that. Okay, so here now for energy level diagram for anion. For anion means it has a positive or a negative charge. Let's just look at this. Draw energy level diagram for the sulfide ion. So for sulfide, so where is that? So it's this, right? So just make sure it's good. Okay, so as you see this sulfide ion, so here is S, it has 16 electrons. Now I'm gonna do the same thing for 16 electrons, just don't want to erase that. Here is 10. Okay. 10. So I just have to erase this. And I have 4 more here in the right. Have 4 more here. It was 16, but he said 2 negative. Okay, when it said 2 negative, it means you need to fill that, right? You need to give 2 electrons into this. That's why I'm just gonna erase that. And I put 6 here. This was 4, now 2 electrons given because the distance is 2 negative. Then I just put that there, right? So it's 1s, 2s, 2p, 3s, 3p, which is filled. No, just put that in energy level like this. And you want to fill this, you fill it according to the rule here, but if you want to take it out, you have to take it out from the outmost ones. So we'll have that example. Creating energy level for cation. Okay, this is the example. So for the zinc atomic number is 30. Let's just continue that there. 3p, so after 3p is what? 4s? 4s through here. And then after 4s is 3d. So it's 3d10, I guess. And then 4p. So I'm just counting to see what is it. 3p, yeah. After 3d, let's go to the 4p. So I'll just count that to see. This is 10. Here is 20, 30. So here is 30, so just don't need that. But he said it's 2 plus, right? So it's a Z and 2 plus means you have to take away electron. When you take away electron, you have to take from highest, the outest one. The outest one is the one that has highest energy level, is 4, right? And 4 is very full. You take the electron from this. So basically you take it and make it empty. See, this one is the energy level is given then. So first it was filled, but when you want to take it 2 electron, you have to take it from 4 energy level. This is the highest energy level. When you want to fill in, you have to follow this rule. What will be the next electron will be filled? Just following that. But when you want to take away electron, you have to think about what is the highest level of energy we can take this. So is that. Now here is energy configuration, and it's -2. I just did put that for you guys. 16, and you get 2 electrons. For iron atom, I did show that to you. For oxygen, I did show that to you. This is electron configuration. The previous one was energy level. It would be the same thing, right? So I'm just gonna erase this maybe a little bit. So the right electron conversion for the chlorine atom. So for the chlorine atom, you know how to do that. So I'm just going to show you practically. So all of the elements here, so for example, hydrogen. For hydrogen, if you do it, it's going to be 1s1. So kind of they are ending at S1, right? This 3, it's going to be 2s. What is this ending? Is ending at 2s1. Okay, here is 3s1. Make sure this is period 2. First group is ending at 2s1. Here is ending at 3s1, and so on, 4s1. So they are ending at s1. And if you do that, so its ending is s2. 2s2, but here. All of this here, if you do it for this 5, what do you think? It's going to be P, right? So 2 of them It's going to be P1. Ending P1 is ending here, all of these elements ending P2. Here, P3, P4, P5, P6. And this one here is ending at D. D1, D2, just put dot, 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 until D what? D10. As you know, is like a 10 electron in a D orbital. Also, this middle one, if you come here, it's going to be F. You see here is 14. F1, F2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's going to be 14 here. Here's this one. For the D, for example, this one, since it's 1, 2, 3, 4, is fourth period, we have to say that 3D1. This is the 1 minus the period that you have here. And here is going to be what? Since it's 1, 2, 3, 4, 5, fifth period, let me 4D1. It's going to be 4D2, and so on. And this one for F is there, right? It's 1, 2, 3, 4, 5, 6 period. It's going to be 6 minus 2. It's going to be, for this one is ending at 4F1. Here ending 5D, for 5F1. This is 4F2, 4F3, 4, and until here, let me 4F14 is filled. Okay. I'm gonna do the eraser. Start. Textbook. Okay, going back to the textbook, it said do it for SN. Okay, I'm gonna find SN here. SN is here. So we have to say everything until there, right? So the first one is gonna be 1s2, 2s2, here gonna be 2p6, and this will be filled. Here is 3s2, p will be filled, 3p6, and here this will be filled, 4s2. Now here is D, right? This is the third one is going to be, its fourth period is going to be 3D10. Now this will be filled as well. 3D10, so it's going to be 4P6 filled. And here is 5S2, and this is your D orbital, right? It's gonna be 4D10 field. And now as in here, this will be 5P2 because 1, 2, 2. Basically, you have to fill all the previous ones in order to get to the SN. You can check the textbook answer and you see. And you with 5P2, and I just said all of that, just following this period. For SN2 positive, so you have to take electron from the outmost. The outmost one is the 5th orbit. If you see the 5th orbit is P2, so this electron, you take it from that, and you see you don't have it. So plus, maybe you just take it away from that, and it's empty now. Okay. Identify the atom that have the following configuration. So this is ending 4p5. So we know that the p is here. 4 means it's 4 pairs. 1, 2, 3, 4 is here. 5 means 4, 5 is 1, 3, 4, 5. It's going to be boron then. Next question said, this one is ending 4d5. 4d going to be in this middle. 4 means you have to, for d, it should be one more than that, right? 1, 2, 3, 4, 5. This is d, I have to add 1. So it's going to be 5. So it's going to be 4d, it's going to be here. 4d5. 1, 2, 3, 4, 5. So it's going to be TC. Let's see the answer. Yes, TC. So shorthand for electron configuration. For example, if the Cl, I just write it that for Cl, because this will be your previous inert gas, Ne, right? I'm going to show that in the periodic table. So see, here is Cl. You just one by one fill until you get Cl. So previous is Cl here. The previous noble gas is Ne. Is everything until here is filled, which is 1s2, 2s2, 2p6 is filled. So to make it shorthand, you put that in the bracket and stuff this, the bracket Ne, and just rewrite the rest of that. The same thing for Sn. Get the Sn here. Sn is there. So the previous noble gas is Kr. So whatever until here, I put that in a bracket. So from here to here it is for Kr. If instead of that, we put Kr in shorthand. So let's just make it shorter for us to do. Okay, this is the question. So write the shorthand electron configuration for the strontium atom. So for Sr, let's just do that. So Sr, where's the Sr? You see that? Okay, let's make it easier. I'm just going back to. So Sr should be somewhere. Oh, here. This is Sr. This is my Sr. So the previous noble gas is Kr, right? It's going to be Kr. I'm going to fill that. So it's going to be what? 1s2, right? Sorry, this is 1, 2, 3, 4, 5th period is going to be 5s2. And this is as simple as it is. Yes. I'm going to erase this. Eraser. Maybe erase that one. So next question, write the shorthand electron configuration for the lead atom and lead 2 ion. Let's do it for lead, which is Pb, right? Let's go here. So Pb, where is that? Pb, where is this P? Pb is there. So previous one is Xe, right? So I'm just doing that for Pb, shorthand, gonna be Xe. And I write the rest. So Xe after that will be what? Is 1, 2, 3, 4, 5, 6. 6 period, so it's gonna be 6s2. And since it's empty, you're going to the f orbital. So since this is 6, it's probably going to be 2 minus that. It's going to be 6 minus 2 is 4. 4F14, so it's filled. Everything needs to be filled. And then we go to the d orbital, right? So it's going to be 1 less than the period. So it's going to be 5d10. And then after that, 2 more for p orbital. Instead, it's 6p2. If you want to do pb lead is plus 2, so you have to take away from the highest level of energy, which is 6p. This will gone. You just have that. I'm gonna just go ahead with the answer here. See, this is what I have there. And then there, just 6p2 is gone because you want to take 2 electrons from this. I'm gonna go to the next. You can do question number 6. 7 and 8, 9. Okay. So you can look at this table. So again, if you want to have a Zn, you want to take an electron, you have to take an electron from highest level of energy. So which is from that. So Zn2 plus means you just take from that, and it's 310, 3d10. Okay. So here is explaining magnetism. We'll do now. Just erase that. So as you see, iron is really in an electric magnet, in the magnetic field, it will be magnetized, right? So to create the explanation for magnetism, let's start with the evidence of the ferromagnetic. Based on the magnetism associated with the electron spin and the presence of several unpaired electrons, initial explanation is that the unpaired electron cause the magnetism. So when you have unpaired electron, they can be free to be aligned in external magnetic field, so unpaired. However, rubidium and palladium immediately below iron, cobalt, and nickel periodic table and are only weakly magnetic. Anyway, look at this example: iron, cobalt, and nickel. Here, iron, it has 1, 2, 3, 4 unpaired electrons. It's very magnetic, right? Here has cobalt has 3 and nickel has 2. So of course, iron is stronger. So I'm asking the student to read this page about magnetism. So the next slide is anomalous electron configurations. So what are the anomalies? Looking at the CR, normally we do like that. But if you see, this is d orbital, it just needs 1 electron to be half filled. So half filled is very stable. So always the nature wanted to be stable. That's why it borrowed an electron from s orbital to become stable. And this is the configuration I have. Also Cu, as you see, you just need 1 electron to be completed, and this is going to be stable if it's completed. You just borrow an electron from s orbital to do that. And in nature, we do that because nature tends to go to the stability. Anyway, when you have 1 electron to be half filled, or you need 1 electron to be fully filled, you have to borrow it and make it stable. And this is exceptions that you need to do. So for these questions, you can do number 2. You can do number 9, you can 10, 13, And that's it.